Now let's do one small experiment. Okay, so when the control comes to the call application, the application task may think that, hey, I will change back to privileged access level. Okay, so what it does is it tries to clear this bit, okay, of the control register. Let's see what happens. Or let's try to move the processor to privileged access level. Okay, let's see whether it is possible or not. Again, we have to read the value of control register, okay, and we have to clear the 0th bit, isn't it? So for clearing you have to use AND operator, 0 cross 0 1. So this will actually clears the 0th bit of this variable, and after that let's pass that value into this KimSys core API. Okay, fine. So now we'll just compile this code and let's see how this works. Okay, so let's download this code. Okay, and let me go to the debug mode and okay, and let's observe all these registers here. Okay, so first let's come to the RTOS init. So I am in the unprivileged access level now, and the control register is 05, right? So because I have changed it to unprivileged access level here, now the control goes to call application, that is here. Okay, so let's come here. Great. So now it reads the value of the control register into the variable value. Let's see how that goes. Okay, so now the value is having the value 0 cross 05. That's correct, right? So now let's see what happens. Here we change the 0th bit. Okay, now the value is having the value 04. Okay, so now you are programming the control register, right? So now let's see whether that is possible or not. Okay, so take a note of the control register value. It is 05. The value is 04. So now that means the control register should come to 04 now, right? So now let's see whether that works or not. And here it is. The control register value is not changed. Okay, because being in unprivileged mode, you cannot touch the control register. Okay, so you should appreciate this beautiful design of the ARM Cortex processor, where once you change the access level of the processor to unprivileged access level, you cannot come back to the privileged access level being in thread mode. Okay, so this is very helpful when you design embedded OS or any RTOS related application. Okay, so what the RTOS or embedded OS kernel does is, before calling the user application, it actually changes the access level to unprivileged. Okay, so to restrict the user access to the restricted resources and the restricted registers. All right, so now how to come back to the privileged access level from the non-privileged access level. So remember, we discussed at this point, handler mode code execution is always with privileged access level. Okay, so that means once the processor comes to the handler mode, the handler mode code execution, that is nothing but the ISR, isn't it, is always with privileged access level. So that means you have to go to the handler mode, and there you have to change the access level back to the privileged access level, and then you have to return from that to the thread mode. Okay, so that's the only way you can change back the access level to the privileged access level. Okay, so now let's see how that can be done. And we know that the application task is failed to change the access level to privileged access level, right? Now the application task is very clever, and now what application task does is it tries to move the processor to the handler mode. Okay, so that's why what it does is it calls this generate interrupt function, let's say. Okay, and its plan is actually, okay, so let's first move the processor to the handler mode. Okay, and in the handler code, okay, let's change the access level back to the privileged access level. So it implements all this code in the interrupt handler. Okay, so let's see whether this plan of the application task works or not. Okay, great. So now let's compile this code. Yes, it works, right? Great, it compiled, and let's download and let's go to the debug mode. And what I do is I just put a breakpoint here, okay, in the application task, and I hit run, and let's check our system registers. Yes, the code is in unprivileged mode, that is done by your RTOS init, and the control register is 0x05. Great. So now let's see whether our application task will be successful or not. Okay, so it comes here. Okay, all right, so it came here, and now it tries to enable the IRQ for this interrupt. Okay, now let's see whether that will be successful or not. Now I'll remove the breakpoint and I hit run. Okay, something bad has happened because the control didn't reach here. So let's see what happened. Let's stop this code execution, and here it is. We are trapped in the hard fault handler. That's because being in the unprivileged access level, the application code, it tried to touch the NVIC register, which has restricted access. Okay, so that's why hard fault exception of the processor triggered, and processor trapped us in the hard fault handler. So this demonstrates that, so once the access level is changed to unprivileged access level, you cannot access, okay, some of the system interrupt related registers of the Cortex processor.